Okay, let's see if we can demystify physics a little bit. The setup I've got here is obviously the same as your one. So here is the floor. I'm simply going to do what you do, which is make that static. We have our bowling ball out of the library, and of course everything works fine. Now, note that my system is set to real time. If you, as I said, have any issues with your card, switch this to frame by frame, which will guarantee frame by frame simulation. And also keep in mind that if you're not sure how fast your system is running, there is an option up here, actually it's under display, to do info, Control F. If you turn that on, you can see the frames per second your system is running at. If that drops down very low, then it's quite possible, as already mentioned in the thread, that the ball will pass through the plane before it gets to strike it or collide with it. So switch to frame by frame if you have any issues at all with simming. I'm going to leave it in by frame. Actually, shall I? No, I shan't, because I just want to see the speed. Right, so here we have our sim going. Everything's fine, and as you've noted, if you come down here and you set an initial force and then run the sim again, you get an initial force, and there's the ball. And if I reset and I type in a bigger value, I'll get a bigger velocity. Right, and there we go, and everything's fine. And this is exactly as per my tutorial. If you watch it, you'll see that that's exactly what I do. But the real thing to note that's really important is that I'm always setting this value at frame 1. In other words, the very head of the timeline. You're not meant to set this value at a later point in time, and there's a reason for that. The thing about physics is that it's kind of working, as the name suggests, about, it's supposed to work the way the real world does. And, you don't have things in the real world suddenly having a velocity, sort of at a certain point in time. So, for example, if you're standing and 30 seconds later suddenly you find something appears out of nowhere traveling at hypersonic speed, in real life that's not something that really happens. Things have to be imbued with motion. So the whole point of this feature, this initial velocity feature, is it's meant to be used right up front to just set things in motion if they don't have any motion in the world that they're about to enter. And that needs to be done at frame 1, not later on in the timeline, which is what you're trying to do. Notice also that none of these values can be animated. All these little arrows are grey. That means that they're global settings, and therefore they're not intended to be animated. So basically what's happening is the system's getting confused, and if I remove the animation from this and I go forward in time to say here, and I set this, if I it doesn't actually matter if the object's kinematic or not, to be honest, but let's just do what you did and you'll see we get the same result. So kinematic on the first frame, remove object animation, let's say go to frame 100, let's go and make it dynamic and give it initial velocity of 500, and we wind back. And now the reason for that is that obviously I didn't animate the ball, so let's go back to frame 100 and rigid state. There's our rigid state, so I'm just going to jump to that. So let's give the ball some forward momentum. There it is, and then it drops. Now that drop you saw there is the previous sim, and if we look down here you can see we've now got this arbitrary value appearing on the initial force of 163.1, and that I think has probably just been made up by the system, based on when this state was asked to be initiated down here at the rigid state. But my point ultimately is that you're not supposed to use the initial velocity in this way. It's not intended to be used this way, and in fact if you read the manual, as I pointed out on the forum, in the iClone manual, it specifically states here, initial motion only takes effect in the first frame when the project is played back. So that is saying that this is not meant to be altered you know, as part of an animated timeline. So if that's the case, how do you get what you want to try and do? Well, what you want to try and do is, let's just remove our object animation. I'm just going to bring this down a bit just to give our screen as much space as possible so you can see what's going on. So in the next video where the woman bowls this ball, I am not using initial velocity at all. I don't touch it. If you watch the video, I go nowhere near that part of the panel. I never use it. And the reason is that the motion is coming from her. And that's what happens in the real world. So let's demonstrate this. Okay, now that we know that we shouldn't be playing around with the initial velocity or initial force, unless you're using it on the very first frame of your timeline, how do we get motion onto our ball? Well, there are two ways to do it. It is all to do with the fact that, you know, this is physics, and physics, you know, deals with transfer of momentum. So for the ball to actually do something constructive, it needs to have a velocity. So at the moment, I've got our ground plane, which is set to static, as we know. We've got my bowling ball, which I've switched to bright red, just so you can see it for the purpose of this video. And if I go to physics, you'll see it's set to dynamic. And if I play, we get exactly what we expect. Now, I'm in real-time mode here, so just keep that in mind. You may need to be by frame if you're having any issues with the sim. It's down to your graphics card and how good it is, how much geometry it can handle. But notice you've got the FPS up here, as I mentioned, and as long as that's a very nice big high count. Keep in mind, iClone runs at 60 frames a second. That's what it's supposed, you know, that's what its internal frame rate is. If you're hitting 60 frames a second, that is good. Anyway, so we know this is what we've got, and we know this. But what we actually want is we want the ball to drop later on in the time and to have some velocity to it, as though, you know, it was being maybe thrown or something. So we can just do this. So I'm going to remove the object animation, so start afresh, blow away the sim and everything. Switch the ball to kinematic, which we know. And now, if I drag the timeline, nothing at all. So let's go to frame 100. And I'm going to animate the ball. So at frame 100, I'm going to move the ball to here. Now I have kinematic animation. I have hand animation. The ball is now moving between those 2 points. Okay, so I might pull the ball back a bit just to get it a bit more velocity, because it's this velocity of the animation that's going to be imparted to the simulation. So when the sim turns on at frame 100, that forward motion of the ball will go into the simulation at that point in time. So let's go to frame 100, and let's say you're now dynamic, and let's rewind. We got our rigid state change down here, and we've got no sim yet, so because you can see the timeline's reset. So let's sim now. So hit play. And there is the imparted motion of the ball. So it hit the end of the time. It's fallen off our world, of course, because it's come off the end of the floor. But now that I've done that, of course, I can turn off the simming up here, which means that this is now baked. So this will not get recalculated down here as per the videos. And now if I play back, I'm playing back a baked simulation. But the most important thing is, if I just scrub the timeline, is at the point of release here at frame 100, the ball is forming an arc. It's not dropping straight down, and the reason for that is it's got the imparted velocity of the forward motion of the animation, and that's kind of what's supposed to happen with physics objects. Okay, there's another way to impart motion to the object, and that is shown in the video where she actually bowls with the ball. And again, the point I'm making is I do not use the initial velocity setting for this in that video. So let's have a look at that. I'm going to remove object animation. I'm going to remove the rigid state for the moment. I could just leave it. And I'm going to turn our simming back on. Let's get a box into our scene. So I'm just going to bring this box in, and I'm going to quickly align it to the ball. So let's just align X, Y, and Z. And then I'm just going to go into move mode and just pull it so it's above the ball, basically. Okay, so we now have a box and we have a timeline. So I'm going to go to, say, frame 200, And I'm going to animate the box all the way across to over here. Let's play that back. There we go, we have an animating box. Now we've still got that state set in this ball, so let's just remove everything, and I'm also going to delete the rigid state. So there we go. So now we've got absolutely no animation on this ball at all, and we've got an animating box. That's all good. Let's link this ball to the box. And this is effectively what I'm doing with the woman's hand in the video. So linkage, pick parent, pick the box, hit play. We get exactly what we expect. So, you know, the ball is now a child of the box, and it's got no animation, so it's just being carried by the box. So let's go to frame 100 and release and unlink the ball from the box. So I'm just going to unlink it at that point in time. And now when we play back, the box just stays, the ball just stays in midair at that point. And that's what it kind of will do, because obviously it's got no animation. Its animation is coming purely from the box. And then when it gets released, of course, it has no animation, and therefore it just stays at that point in time. Let's go to frame 100 again and switch our state. So let's make sure we've got the ball selected, and we're going to switch to dynamic. And now the dynamics will take over, and we have our rigid state switch on our timeline. So now we're going to get a sim happen at that point in time. So let's just run to the end, and there we go. Now we have our physics sim. Again, I'm going to switch it off up here, so that will kind of effectively means that this is now baked. And when I play back now, I'm playing a baked sim back. But the important thing to note is the velocity transfer. So if I scrub the timeline, we can see it'll be easier. At the point of release, the ball is dropping in an arc again. And that velocity, just like when I animated the ball directly, that velocity is coming from the parent that the ball is attached to that point in time when it's released. So at that point, it's been released from its parent, and it's completely now simulating in the kind of physics world. And that's basically how it works, and that's exactly what I'm doing with the woman's arm. When she throws the bowling ball, it's the arc or pendulum motion of her arm that is imparting that velocity to the ball at the point of release. And that's basically the other way you can impart motion into objects in iClone. And the big thing to remember, just to reiterate about this initial force, the whole point of this initial force is it's designed to allow something to have motion at frame 1. Imagine frame 1, that's your start of your history of your world. There is no minus time, there is no negative time before frame 1 or time code 0. Nothing exists. So if you have to have something, to have a velocity right at the very beginning of your animation, then that's what this setting is designed for. Otherwise, an object has no motion, in other words. And obviously I can impart motion to an object, as you've just seen. That's exactly what I've been doing. But I can only impart motion to an object starting at frame 1 and going forward in time or in history. So the whole point of the initial velocity is really to impart motion, dynamic motion, to an object, so that it starts at the very first frame in the world, as far as time is concerned. If you want to impart motion to an object after the first frame, then you need to do it the way I've shown you, which is like use standard object interactions in iClone. And this is exactly what's mentioned in the manual. If we look at the iClone manual here, you'll notice right at the very top it says simulation via reaction with the environment and other physics objects. Okay, a dynamics physics object will not contain any animation unless it interacts with another object. However, in iClone 6 you can assign initial motion for a physics object, giving it initial force to move it or rotate it in any particular direction. So the whole point of the initial motion is only to be used at the very beginning, because there is no time before frame 1. That's why it's there. But once you're away from frame 1, so you're at frame 100, there is time. You've had 100 frames of time, and that means that you can have imparted motion to an object prior to frame 100, which is exactly what we're doing here. Kind of hope that makes sense. If not, obviously, please come back in the forum and we'll go from there.